Hello everyone, this is Cavell, and today we'll be talking about imaginary and complex numbers. So, what's an imaginary number? Well, an imaginary number is any number, right, that is multiplied by an imaginary unit of I, okay? So, imaginary units as follow is basically A times I, right? Or actually, by default, it's usually B times I, where B is just any real number. Okay? And now you're probably asking me, hey, Cavell, what does I mean? Is that like a variable? What is it, right? So to put things into context, right, mathematicians are kind of stubborn, right? They always want to find a solution to a problem. And, back then it was impossible to find the square root of a negative number, right? So I was invented, or I guess maybe discovered, in order to solve the square root of negative numbers, right? So I is equal to square root of -1, okay? And what's important about I is that there are 4 different powers of I, okay? And what do I mean by that? So I to the first power is equal to square root of -1. I to the second power, right, is equal to -1, okay? I to the third, right, is basically negative I, right? Or in other words, you could think of it as like this times this, right? And then I to the fourth, right, is -1, okay? And now, what's so special about I is that when you get higher powers of I, right, you can find out, you'll find out that the values actually start repeating itself, okay? So all the all the different possible powers of I will either equal to this, to this, to this, or this, okay? So for example, right, if I have I to the 63, right? To find out what this is equal to, I'm not going to find out what I times I times I times I 63 times is equal to. Rather, I'm looking at the exponent, and I'm going to divide by 4, and then find its remainder. That remainder, right, is going to be a single digit. That's going to tell you what this power of I is equal to, okay? So now if I divide 63 by 4, right, I get a remainder of 3, okay? In other words, this is basically the same thing as I cubed, right, which this is equal to negative I, okay? So as you can see, right, the power of I, right, as soon as we keep on repeating it, right, they end up going back to the same values that you see here, right, of square root of -1, negative I, and then I squared is -1, okay? So this is that's pretty important, right? So let's do another example. So let's see. Let me erase this. So we'll have this up on the side because that's definitely very important. Okay. So as you can see, right, what I said before, I is always repeating. So let's do another example. Okay. Let's just say I to the 35th. Right. Same idea. To find out the value of this, I need to divide the power of I by 4 and find its remainder, right? And if you divide 35 by 4, right, you get a remainder of 3 because 4 times 8 is 32, and 32 is 3 away from 35. Hence, this is also equal to I cubed, which is equal to negative I. Okay. Let's do another example. If I have I to the 64, right? If I look at the exponent, which is 64, if I divide by 4, right, I get 16. Okay. Yeah, 16. So that means 4 goes into 64 perfectly, right? Which means the remainder is actually 0. Okay? So when the remainder is 0, that basically means this is the same thing as I to the 4. Okay? So in other words, this is equal to negative 1. All right? So to put things into a better perspective, right? If I have I, so if I have I to some power, right? If A, right, mod 4, right, is equal to, well, if you don't know what mod means, but let's just do A divided by 4, right? If A divided 4 and remainder is equal to 0, this, if the remainder is 0, right, this is basically I to the 4th. Okay. If remainder is equal to 1, right, this is I to the 1. If remainder is equal to 2, it's basically I squared. If remainder is equal to 3, this is I cubed. Okay? So that's how you can tell, right? Now, to move on, right, we also have complex numbers. Okay? Complex numbers is made up of a plus or minus bi. Okay? So both a and b are real numbers. Okay? So what I wrote here basically means a and b are part of the set of all real numbers, right? And it basically says that a complex number is the sum of a real number added to an imaginary number. Hence, you get complex numbers. Okay? So, I mean, in all honesty, you could write 0 plus I, and that would be technically complex um, because you have just I, and you have a number that's being added to it, right? A real number. So if you really think about it, all imaginary numbers are complex numbers, right? But not all complex numbers are imaginary, because imaginary simply implies that it's just an integer, or sorry, a real number multiplied by I. Okay. So there are a few I would say applications of I. I think when you work with electricity and engineering, you'll deal with a lot of I's. I believe when you work with ohms and stuff like that, you work with I. There's also something called complex analysis, and you learn about the different functions of I, and some important theorems comes from there. But just to make it simpler, right? So one thing we can think about is how to use I in some math problems, right? So for example, if we have a problem call that goes x squared plus 1 is equal to 0, right? And we say, okay, can we find a value of x such that this is true, right? Well, we'll solve for x, right? So we subtract 1, and I get x squared is equal to negative 1, and I square root, and then you realize, anything squared is always going to be positive. So that's where complex and imaginaries come in. Right? So we have x is equal to plus or minus square root of negative 1, or x is equal to plus or minus I. Alright? So that means x is equal to I and negative I, right? So let's check that, right? Let's check that. So Cavell, you say x is equal to I or negative I. How do I know that's true? Well, I can plug these values back in to the original problem, right? So let's check for I. This is basically saying I squared plus 1 is equal to 0. Remember what I squared is? It's negative 1. So I have negative 1 plus 1 is equal to 0. Yes, that is true. Negative 1 plus 1 is 0, right? Now let's check negative I squared, right? So this is x equals to negative I, and this was x equal to I, right? And if we look at it, right, we can see that negative I is being squared, right? So negative I times negative I, right, is basically positive I squared plus 1, right, is equal to 0, right? Remember what I squared is equal to, right? I squared is equal to negative 1. So this is still the same thing as negative 1 plus 1 is equal to 0, which is obviously true. Okay? So it's important to see that whenever you do these math problems, you should always check your work, right? Okay, let's do another example perhaps. Let's just say I have let's see, x squared plus 3x plus 9, okay, is equal to 0, right? I want to find the solutions to this equation, right? And we can see that we can't necessarily factor this equation, right, or this quadratic, because there isn't two numbers or any two real numbers that multiplies to 9 and adds to 3, right? So we use the quadratic formula. So x is equal to negative b plus or minus b squared minus 4ac is equal to 2 times 1, right? So I have x is equal to negative 3 plus or minus, right? 9 minus 4 times 9, which is 36. So 9 minus 36 is negative 27 all over 2. And I get x is equal to negative 3, right? Plus or minus, right? Anytime you see a negative number underneath a square root, you can take it out and make it as I. So square root of 27. So I took out the I, took out the negative 1, right? Because if you remember, I is equal to square root of negative 1. So square root of negative 27, right, is basically the same thing as square root of negative 1 times square root of 27, right? And that means I can change this into I and take it out, right? So we simplify, we get x is equal to negative 3 plus or minus, right? 3i times square root of 3, because 27 can be represented by square root of 9 times square root of 3. Square root of 9 is 3, square root of 3 is, you just leave that as is all over 2, right? So my solutions are x is equal to negative 3 plus 3i times square root of 3 over 2, and x is equal to negative 3 minus 3i times square root of 3 all over 2. So both of these answers satisfy this equation that we have, x squared plus 3x plus 9. All right, that's it for today. So this is just a brief overview of imaginary and complex numbers with a few examples. All right, thank you for watching. Bye bye.